In this tutorial, we are going to go over some practice questions under complex numbers. So we're going to move from basic operations, computations such as addition, subtraction of complex numbers, simplification of complex numbers, and also expressing given forms in the form of a plus ib. So let's get started. Okay, question 1. Simplify. Let's say you have been given 2 plus 3i minus negative 7 plus 6i. So in case you're meeting complex numbers for the first time, make sure you watch our introductory video on complex numbers to understand what complex numbers are. So basically, complex number, you need to understand that I is basically equal to the root of negative 1 and I squared is equal to negative 1. So we need to understand that. Okay. So now let's get started. So by subtraction and addition, you get to look up the like terms. So just as we get to do it under normal algebra, so we have 2 plus 3i. I'll then distribute the negative. So negative 7 will become positive 7. The 6i will become a negative 6i. At this point, we correct the like terms. 2 plus 7 is a 9. 3 minus 6 is a negative 3i. So we simplify that. Okay. Let's move. Now let's say you've been given negative 2 plus 3i. Then this is what? It is squared. How do you get to simplify that? So we basically understand that when something is squared, we have negative 2 plus 3i. Again, negative 2 plus 3i. What happens there? So negative 2 by negative 2 is going to be a 4. Negative 2 by 3i is going to be minus 6i. 3i by the negative 2 is also going to be minus 6i. Then negative or positive 3i by positive 3i, we're going to have a 9i squared. So we have 4 minus 12i. Because the middle part, these are like terms. 6 plus 6 is a 12. So I squared, we said I squared is equivalent to what? A negative 1. So you can put a negative 1 there. So we have 4. 9 by negative 1 is a minus 9. Minus 12i. What can we do there? So 4 minus 9 is what? Is a minus 5. Minus 12i. So we've simplified that. We've expressed it in the form of a plus b high. Okay. So let's look at more computations. Let's say we've been given 4 plus I root of 3 plus negative 6 minus 2. That is minus 2i root of 3. How do you get to approach that question? So equally, we are just doing addition. That's why we have 4 plus I root of 3. So we maintain what is in the brackets, minus 6 minus 2i, because positive doesn't change anything. We are adding. What are the like terms? So we have 4 minus 6, which is a negative 2. Then we have high and a negative 2 high. So I is attached to a 1 there. So 1 minus 2 is going to be a minus. So we have a minus I root of what? Root of 3. So we've expressed it in the form of a plus ib. Let's look at a different form of a question. Now in this question, let's say we've been given 2 minus 3i divided by what? Divided by 1 minus 2i. So here we want to express this in the form of a plus ib. What we need to understand is this is division. And whenever you're dividing complex numbers, you have to multiply by the conjugate of the denominator. So if you have a complex number in the form a plus ib, its conjugate is going to be shown by a bar on top, which is going to be, you change the sign of what? The imaginary part. So if you look at the denominator, what is its conjugate? It's 1 plus what? 2i. You change the sign. So you even multiply it with the numerator. That's how you get to divide complex numbers. So multiplying what we have for the numerator, 2 multiplied by the I, we have a 2i. 2 multiplied by the 2i there, we have a 4i. Then we go to the negative 3 by the I, it's going to be minus 3i squared. Negative 3 by 2 is going to be a minus 6i squared. Over what? So we have to divide by 1 times 1 is a 1. 1 times 2i is going to be what? It's going to be plus 2i. Negative 2 by a 1 is going to be minus 2i. Negative 2 by positive 2i is going to be negative 4i squared. So the basic idea is whenever you're multiplying a complex number by its conjugate, it's just advisable to multiply the like parts. So 1 times 1, which is a 1. Negative 2 by 2 is going to be a minus 2i squared. Or sorry, a minus 4i squared. Because the middle part is always going to cancel out. 2i minus 2i will go. So what is going to remain at that stage? So what has remained is we have 2i plus 4i, that is 6i. So where there is I squared is equivalent to a negative 1. So we have minus 3, negative 1, minus 6, negative 1. Over what? Over 1 minus 4. So where there is I squared, we put a negative 1. So we have 6i, that is a positive 3, that is a positive 6. Then we have 1 plus a 4. So we have 6 plus 3 is a 9, plus 6i over 5. So at that stage, if you divide by 5, you have 9 over 5 plus 6 over 5i, which is in the form of what? A plus ib. Okay. So we still have some more questions to look at as we practice simplification or simplifying of complex numbers. Now, let's say we have 2i, 2 plus I, multiplying by negative 1 plus 2i. Then we have 4 minus 3i. How do you get to simplify that? So 2 by negative 1 is going to be what? It's going to be minus 2. 2 multiplied by 2i is going to be a 4i. Negative I by negative 1 is going to be minus I multiplied by 2i is going to be 2i squared. Then in the other brackets, we'll maintain what we have. So the like terms there, we have negative 2. 4i minus I is 3i. 2i squared is the same as 2 multiplied by a negative 1, because we basically understand that I squared is equal to negative 1. So negative 2 minus 2, we're going to have a minus 4 plus 3i. Then in the other brackets we have what? We have a 4 minus what? Minus 3i. How do we get to simplify it? So we have negative 4 by 4, a minus 16. Negative 4 by negative 3i is going to be a 12i. 3i by 4 is going to be positive 12i. 3i multiplied by the negative 3i is going to be a minus 9i squared. Okay. So at this stage we can simplify. We have a minus 16. 12i plus 12i is 24i minus 9i squared. So I squared, we said, is a negative 1. So we have a minus 9 multiplied by a negative 1. So we have negative 16 plus 9 plus 24i. 9, 16, subtract 9. What are you going to have? So from your 16, remove 6. You're going to remain with a 10. Then you still need to remove 3, so you remain with a negative 7. So we have negative 7 plus 24 high as our form in the form of a plus ib of that complex number. So what are we trying to say? In summary, what we're trying to say is, whenever you have two different complex numbers, you get to add them. Okay? Whenever you have two complex numbers that you're getting to add, it's just basically easy to understand that just go for the like terms. Okay? For the addition. That is the way complex numbers are, for both addition and subtraction. For division, the basic idea is, if you have a plus ib being divided by x plus iy, what you're supposed to do is you need to multiply by the conjugate of what? The denominator. And we are saying the conjugate, you basically have to change what? You have to change the sign in between. Okay. So the conjugate should also be multiplied by the numerator. And as you get to deal with your multiplication, it is very important to note that I squared is basically equivalent to what? It's basically equivalent to a negative 1. Okay. Now, let's say you've been given negative 2 plus 3i squared over what? 1 plus 2i. We need to express this in the form of a plus ib. So feel free to pause the video and try that question out. Okay. So this is basically equivalent to negative 2 plus 3i multiplied by negative 2 plus 3i. That's what it means when it says squared over 1 plus 2i. So I would want first of all to simplify what is on the numerator before we get to divide. So negative 2 by negative 2, we're going to have a positive 4. The same negative 2 multiplied by the 3i is going to be a minus what? Minus 6i. 3 multiplied by the negative, that is also going to be minus 6i. 3 multiplied by the 3i is going to be 9i squared over what? 1 plus 2i. Okay. So 4 minus 12i, because 6 and 6 are like terms, they are all attached to I. Then plus 9, we'll put a negative there. So let me write that better. We don't have enough space there. Write it on top. So we have 4 minus 12i plus 9. Where there is I squared. I squared is equivalent to what? Negative 1 divided by 1 plus 2i. Any more like terms that we have? So we have 4, 9. So 4, 9 by negative 1 is a minus 9, minus 12i over 1 plus 2i. So I've just multiplied the negative by the 9 and I've moved it there, so that we correct the like terms. 4 minus 9 is a minus 5, minus 12i over what? 1 plus 2i. At this stage, we can now divide by multiplying by the conjugate of what? The denominator. So the conjugate in this case is changing the sign of the imaginary part, which is what? Giving us a minus 2i. So we do the same to the numerator. So what are we going to have? So negative 5 multiplied by the 1 is a negative 5. Negative 5 multiplied by the negative 2i is going to be 10. 10i. Negative 12 multiplied by 1 is a minus 12i. Negative 12 multiplied by a minus 2 is going to be a positive 24. Then it will be I squared over what? So for the conjugate, I said multiply the real parts by the real parts. 1 times 1 is a 1. 2i by a minus 2i is going to be a minus 4i squared. Okay. So negative 5. 10 minus 12 is a minus 2i. So these are the like terms. They are like terms because they are all attached to I. The other part, 24I squared, is 24 by a negative, because I squared is equal to -1. On the denominator we have 1 minus I squared is -1. So I've substituted at every point where we had I squared, I've put a -1. So we have -5 minus 2I minus 24 over what? 1. -4 by -1, you're going to have what? We're going to have a +4. So -5 minus 24 is going to be a -29 minus 2I over 5. So you can divide by 5, so that we have -29 over 5 minus 2I over 5. So we've basically expressed it in the form of a plus ib, where a and b are rational numbers. Okay, I've got some more interesting questions. What if I gave you 5 plus 3I multiplied by 5 minus 3I? What would you do? So 5 times 5 is 25. 5 again multiplied by 3I is a minus 15I. 3I multiplied by 5, that is positive 15I. 3I again multiplied by the negative 3I is going to be a minus 9I squared. Okay, so we have 25. Negative 15 plus 15 is a 0. Where is I squared, we'll put a -1. Okay. So what basically do we have? So we have 25 plus 9. 25 plus 9 is what? That is going to be a 34. Okay. So now, if we express it in the form of a plus ib, so a basic idea is that if you look at what we were actually multiplying there, we are multiplying a complex number by its conjugate. So we don't expect to have the high somewhere. We're just going to have what? A real number. And that's what we have. Okay. How about this question? How would you simplify it? You have root of 2 over 2 plus root of 2 over 2i, then squared. How is it different? A combination of sides with complex numbers. How do you get to simplify that question? So now what we have requires us to multiply the 2. So we have a product of that. So we have root of 2 over 2 plus root of 2 over 2i multiplied by root of 2 over 2. So that's what it means when they say squared. We multiply itself. So I'll start this by that. Root of 2 by root of 2. So there's a tutorial where we talked about sides. And we said when you have the root of 2 by root of 2, it is the same as 2 to the power 1, which is just a 2. So what do we have there? In other terms, root of 2 times multiplied by root of 2 is the same as 2 times 2, which is root of 4, giving you 2. So whenever you're multiplying identical things under the square root, you have the exact result itself. So root of 2 by root of 2 is going to give us a 2. 2 times 2 is going to give us a 4. Okay. Then again, this very part multiplied by the other part, we're going to have the exact same result, except it is going to be attached to an I there. So put I. I'll move to the other part. I'll go to the other part. This one multiplied by that. So the numbers are going to be the same. It's to be 2 over 4. But there's an I attached there, so it will be high. Then again, this very part by that part, the numbers will still be the same. Now it will be I squared. Okay. So at this stage, what we get to have So we now have 2 over 4 is the same as 1 over 2. So 1 over 2 plus 1 over 2 is going to be what? Or 2 plus 2 is a 4. 4 over 4. So we just have, we're going to have what? Just I. Then the other part, we have 2 over 4. 2 over 4 is the same as 1 over 2. Then we have I squared. I squared is the same as what? Is the same as negative 1. Okay. So we have 1 over 2 plus I. 1 over 2 by I is going to be 1 over 2 by negative 1 is going to be 1 over 2. So 1 over 2 minus 1 over 2 plus I. Basically, we have what? We have I. So our final answer is I for that question that we had. Okay. Now, try out this one. Try out this simple one. Given 2 plus 3i divided by 3i. You can also try out this one. 1 plus I root of 2 over root of 3 minus 2i. And you can also try out 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i. So try out these questions before we get to move to solving the equations under complex numbers. Feel free to pause the video and try them out. Okay, I'll just offer you at time to pause and try the questions out. So for the first one, as you might guess, what are we dealing with there? We're dealing with division. And what do we get to do for division? How do we get to approach a question? So it would require us to do what? It would require us to multiply by what? By the conjugate. So we can multiply by negative 3. Negative 3i, negative 3i. Because it's like we have an imaginary real number 0 plus 3i. So its conjugate requires us to change the sign of the imaginary part, and that's why we have a negative 3i. So multiply that on top. 2 being multiplied by negative 3 is going to be minus 6i. 3i multiplied by negative 3i is going to be a minus 9i squared. The denominator part, 3 times 3 is a minus 9, then I squared. So this can simplify to negative 6i. I squared is the same as negative 1. Negative 1 by negative 9 is going to give us a positive 9. The denominator, negative I squared, is the same as negative 1. Negative 1 multiplied by negative 9 is going to be a positive 9. So at this stage, we can simplify this to negative 6i over 9 plus 9 over 9. The highest common factor between 6 and 9 is a 3. So we have a minus 2 over 3i plus 1. So we've expressed our complex number in the form of what? A plus ib for the first part. Okay, moving on to the second one. For the second one, we have 1 plus I root of 2 over root of 3 minus 2i. So this one just basically is asking us to divide. So by division, we said you multiply by what? By the conjugate. So we change the sign of imaginary parts. So since it's a negative, it becomes a positive. So 1 times that, we have root of 3. 1 times 2i, we have 2i. Then I'll move to the next part. Negative I root of 2 by root of 3. We're going to have I root of 2 times 3 is 6. Then this by that, we're going to have I times I is going to give us I squared. Root of 2 by 2, we're going to have 2 root of 2 there. Okay. Over what? So root of 3 by root of 3, we have we have what? A 3. Negative 2i by positive 2i, we have a minus 4 I squared. Okay. Any like terms there? So root of 3 plus 2i. Then what else do we have? We also have I root of 6. Then where there's I squared, we can put what? A negative 1. So we have minus 2 root of 2 over 3. Where there's a I squared, we can put what? A negative 1. So negative 1 by negative 4, we're going to have a positive 4. So at that stage, we now have root of 3 plus 2i plus I root of 6 minus 2 root of 2 over what? Over a 7. Okay. What do we get to do at that stage? So we have root of 3 minus 2 root of 2 plus 2i. So I can factorize the I there. So I have 2 root of 6, then I'll put I outside. Over what? We have 3 plus 4, which is a 7. So we can divide by 7. So over 7 over 7. So we've now expressed that in the form of a plus what? IB. Okay, then for the other question that you are supposed to try out, we have 1 plus 2i divided by 1 minus I plus 1 minus 2i over 1 plus 3i. How do you get to simplify that? Okay, so you're dealing with addition here of fractions, and it is a requirement that whenever you're dealing with additions of fractions, you need to come up with a common what? You need to come up with a common denominator. So what is the common denominator there? We have 1 minus I, then you have 1 plus 3i. So you just multiply them. So now, divide this into that. You are going to remain with the other part. So you are going to multiply 1 plus 2i on your numerator, multiply by the opposite one, which is 1 plus 3i. Plus, the other part, the same thing is going to happen. You are going to multiply the 1 minus 2i. 1 minus 2i multiply by the opposite denominator, which is 1 minus I. Okay. What do we have then? We can begin multiplying. 1 times 1 plus 3i, we have 1 plus 3i. 2i by 1, it's 2i. 2i by 3i, we have 6i squared. So I've multiplied the first two there. The other parts, we have 1 multiplied by what is in the upper bracket, 1 minus I. So it's going to be 1 minus I. Negative 2 multiplied by a 1 is going to be minus 2i. Negative 2 by a negative I is going to be a positive 2i squared. This is all supposed to be divided by what? 1 multiplied by 1, it's a 1. 1 by 3i's, it's 3i. Negative I by 1 is a minus I. Negative I by 3i is going to be a minus 3. I times I is I squared. Okay. At this stage, we need to note that negative I squared is basically equivalent to what? So I squared is basically equal to a negative 1. So we have like terms there. So I can say we have 1 plus 5i. Where there is I squared, I'll put a negative 1. So we have 6 by negative 1 is a minus 6. So we have 1 minus I, the other part there. So we have 1. Then negative I minus 2i is a minus 3i. So where there is I squared, we'll put a negative. So 2i squared is going to be a minus 2. This is all divided by what? 1 3i minus I is a positive 2i. I squared is a negative 1. Negative 1 by negative 3, we have a positive 3. Like terms on the numerator, 1 minus 6 plus 1. So 1 plus 6, 1 minus 6 is negative 5. Negative 5 plus 1 is a minus 4. Minus 2, we have a minus 6. Okay. Is that okay? So minus 6. 5i subtract 3i, we have what? We have 2i over 1 plus 3 is a 4, so we have 4 plus 2i. At this stage, we've not yet taken it to that form, so we can now multiply by what? The conjugate. So the conjugate of a denominator is 4 minus 2i. We've just changed the sign of what? The imaginary part. By the way, a complex number is also made up of what we call the real part and the imaginary part, just in case you didn't take time to watch our video explaining the concept of complex numbers. So x is referred to as the real part, then the part attached to I is said to be imaginary. And this is basically what makes complex numbers different from a set of real numbers, because it includes numbers that are imaginary. The root of negative 1, for example, that is imaginary. Okay. So what do we have? Negative 6 multiplied by 4 is going to give us what? 6 by 2 is 12, by 4 or by 2, 24. So I have a minus 24. Negative 6 by a minus 2i, we're going to have a positive 12i. Then 2i plus 4 multiplied by 4 is going to be 8i. 2i by negative 2i is going to be minus 4i squared over, for our denominator we have 4 being multiplied by 4, 16. 2i by negative 2i, we have a minus 4i squared. Okay. So what do we have? We have a minus 24. 12 plus 8 is 20. I squared is equivalent to a negative 1. So there we have a negative 1 by negative 4, give us a 4. On the denominator part, we have what? 16 minus 4i squared. I squared is negative 1. Negative 1 by negative 4 will give us a positive 4. So we now have negative 24 plus 4 is a minus 20 plus 20i divided by what? 20. Divide by 20, you have negative 1 plus I. Okay. So we've expressed our solution in the form of a plus ib in this case. Okay. Now let's get to look at some of the things that we get to simplify. So we are asked to express the following in the form of a plus ib. The first one, I cubed. The second one, 1 over I to the power 5. Then the other one, I to the power 15. And the last one, I to the power 1200. So before we get to look at that, let's try to simplify what we have first of all. So I to the power 3. For us to simplify this, we need to understand that I squared, we've said it is equivalent to a negative 1. Okay. So I3 in terms of multiplying I squared is the same as I multiplied by what? I squared. I squared by I is I cubed. So we do know that I squared is basically equivalent to a negative 1. So we can say we have I multiplied by negative 1. So therefore I cubed is the same as negative what? I. We've simplified the first one. Okay. Feel free to pause the video and try out the second one. We have 1 plus 1 over I to the power what? I to the power 5. Okay, what basically do we have there? How do we get to look at that question? So I to the power 5 is the same as what? So in terms of 2, I5 basically involves us multiplying I to the power 2 multiplied by I to the power 2, which is going to give us I to the power 4 multiplied by I. So I to the power 2, we know it is what? We basically know it is negative 1. So negative 1 times negative 1 multiplied by I. So we have a positive I. So I to the power 5, it gives us that. It gives us what? It's giving us a I. Is that true? I to the power 2 multiplied by I to the power 2. Remember, we are saying I squared is equivalent to negative 1. So how many i's do we have in this case? Okay. So I squared is equal to negative 1. So if we have I to the power 4, it is also going to be negative 1 to the power what? Excuse me. That is going to be the same as to the power 2. Okay, let me simplify this. What I'm trying to say is, when you have I to the power 4, this is the same as I squared to the power what? The power 2, which gives us what? We know that I squared is basically what? Is basically a negative 1, right? So negative 1. So we are going to have a positive value there. So therefore, I to the power 5 is the same as negative. So I to the power 2 multiplied by I to the power 2 multiplied by I. I to the power 2 is negative 1. I to the power 2 is negative 1 multiplied by I. So we have a positive what? I. So I to the power 5 is the same as I. So we have 1 over I there. Okay. So you can divide that into the 1 by multiplying by what? Negative I. So that you express it in the form of L plus IB. So we are going to have negative I over negative I squared. So we have negative I over I squared is the same as what? Is the same as negative 1. Okay. So what do we get to have there? Remember, all the numerator there is supposed to be a negative. So we have negative I over 1, which is just negative I. So we've simplified. That is the same as negative what? I there. Feel free to pause the video and try out C, which is I to the power 15. Then the last one, on the part of simplifying, that we would want us to have a look at is I to the power 1002. Okay, so I to the power 15, you would want to express the I in terms of even powers. So it's the same as I to the power 14 multiplied by I. But we do understand that I to the power 14 is the same as I squared to the power what? 7. Because 7 times 2 is going to give us a 14. So I squared is equivalent to a negative 1. So I have negative 1 raised to the power 7 multiplied by I. So now what is the basic idea there? We do understand that whenever we multiply a negative number, let's say negative 1 times negative 1, that is what? That is going to be a positive 1. Now, whenever you multiply it odd times, for example, 3 times, 5 times, it's going to give you a negative value. So I to the power 7, or negative 1 to the power 7, I can write it also as negative 1 to the power 6 multiplied by negative 1, which is going to give us Negative 1 raised to the power to an even power 6 is going to be a positive 1 by negative 1, which is going to be a negative 1. So whenever you get to raise a negative 1 to an odd number, it's going to be a negative. So negative 1 to the power 7 is negative, multiplied by I. So I15 is the same as negative what? Negative I there. Okay. That is what we're trying to say. So remember when we said a case where I had talked about I to the power 5, we had I to the power 4, so it was a different case. How do you get to simplify I to the power 200, 1200, 1002? So what number can you multiply twice to give you that? So I'll think of I, then I'll put a 2 inside. So 1002 divided by 1002 divided by a 2. So it's 501. So you can multiply 501 times to give you that. So that is the same as what? So I squared is the same as negative 1. So we've raised it to the power 501. So 501 is what? Is it an odd number or an even number? It is basically what? It is basically, we can clearly see that what we have is what? It's not an even number. It's what? It's an odd number or an odd power. So how do we get to simplify that? So remember where we have put so we have 501. So where we've put that, the negative 1, we are multiplying it 501 times. 501 times is an odd number, which tells us to say that we need to expect a negative what? A negative value. Okay. That is the way we get to look at these questions. Okay. Let's try to look at different forms of questions now. So now in this case we are expected to solve some of these equations here. Okay. So if you are tired, take a break, take a chill, and come back, pause the video, feel free to relax and then get to continue. It's very, very important that you get to watch this video until the end because these are very, very important things. Okay. So now let's say you've been given 3 plus 5i is equivalent to a plus bi multiplied by 1 plus I. In this question we are taught to find the value of a and b if these two are equal. So on the left we'll maintain what we have. Then on the right hand side we need to expand that. A times 1 is what? It's a. A by the I is going to be ai. Bi by 1 is going to be bi. Bi multiplied by the I is going to be bi squared. 3 plus 5i is equal to. So we want to first of all get to substitute. Where there is I squared we put a negative 1. So negative 1 by b is going to be what? A minus b. So I've corrected the real parts. Then the imaginary parts we have a plus ib. So I can factorize out the I. So I have a plus b. Then I put the I outside since it's common. Okay. So what do we have? So we can now equate the two. A plus a minus b should be equivalent to the real part there, which is a 3. Then a plus b on the other side should be equivalent to a 5 as the imaginary part. So looking at the first equation, if I get to make a the subject, we're going to have 3 plus what? Plus b. Getting that and substituting in the second equation, where there's a, I get to put 3 plus b. We have 3 plus b. So where there's a, I've substituted that. Then plus b being equal to 5. So we have b plus b is going to give us 2b. Then the 3 can go the other side, so that you subtract from 5. 5 minus 3 is going to give us what? A 2. Therefore our b is equal to a 1 there. We found the value of b. We can also find the value of a. So therefore our value of a is going to be 3. Our b is 1. So we have a 4. So we found the value of a and b in this kind of an equation. So in a case where they give you something like that, what is very important to note is equate the real parts and also the imaginary parts, equate them together, come up with two simultaneous equations when you get to determine the values of a and b respectively. Okay, let's look at one more. Basically, we can look at two more. Now let's say you've been given 6 plus 3i being equivalent to 4i minus 30 multiplied by x plus yi. On the left, on the left answer, we just have that. On the right, we have 4i. 30 by x is minus 30x. Negative 30 by the y is a minus 30yi. We can correct the right terms. On the left hand side, this is imaginary. So let me start first of all with the real part, which is minus 30x. For the imaginary part, we have 4 minus 30y. Then I can factorize what? The common part I. Then I can come up with two equations. First equation, connecting the real parts, is going to be minus 30x being equal to 6. Then the other part is going to be 4 minus 30y being equal to what? To 3. So we've come up with two equations. So if you make x a subject in this equation, x is going to be 6 over 30, which is going to be negative what? 1 over 5, because 30 divided by 6 is going to give you 5. So since we have we've already found our value of x there, then the good part about this equation is x is the only thing attached to the real part. Then the I is only attached to the 30. The y is only attached to the imaginary part. So in the other equation, negative 30y is equal to 3 minus 4. So which is going to be negative 30 being equal to 3 minus 4 is okay, let me write that better. So we have negative 30 y negative 1. Y is going to be 1 over what? 30. So we found the values of x and y in that equation. Now feel free to try out this one. Let's say you've been given, for the same equation, you've been given a to the power 3, a plus I to the power 3 being equal to 18 plus 26i. How do you get to look at this question? So a times a is going to be what? So that is the same as a plus I squared, then a plus I. Then we have 18 plus 26i there. So a times a is a squared. A times I is going to be ai. So what I'm doing first of all, I've put that, I've wrote it twice separately, so that I try to expand it. So a times a is a squared. A times I is ai. I times a is also going to be ai. Then I times I is going to be I squared. So I've expanded the a plus I squared. Then that should be multiplied by the other part, which is just a plus I. And this should be equivalent to the right hand side, which is 18 plus what? 26i. What do we have? So we have a squared plus 2ai. I squared is the same as negative 1, so I'll put a minus 1. So I have a plus I there, being equal to 18 plus what? Plus 26i. let's get to multiply now. A multiplied by a squared is going to be what? A to the power 3. A multiplied by 2ai is going to be 2a squared I. Then a multiplied by 1 is going to be minus a. Okay. So we can now move to the I. I multiplied by a squared is going to be, so let me just write that better. So a by, that is minus a. So I by a squared is going to be a squared I. Then I by 2a, so the middle part by that is going to be 2a I squared. Then I by negative 1 is going to be a minus I, being equal to 18 plus 26i. So what do we have? We have a to the power 3 plus, what other real part do we have? We have minus a. Okay. So we have minus a. Then the imaginary parts, we have 2a squared plus a squared I. What do we have for that? So those are like terms. They can give us what? They can give us 3a squared I. Then for the imaginary part again, we also have 2ai what? 2a I squared. So I squared is the same as negative 1, so you can put a negative 1 there, minus I, being equal to 18 plus 26i. So we've noticed something there. So the 2ai squared doesn't belong to the imaginary part. It's basically supposed to be attached to the real part. So we have a to the power 3 minus a. So then that part is going to be minus 2a. So I've added it to the real part. So for the imaginary, we are now remaining with 3a squared I minus I should be equivalent to 18 plus 26i. Okay. We can now come up with equations here. So for the real part, we have this part. Okay. So we have a to the power 3 minus a minus 2a. So a minus 2a, that is something determinable. It's minus 3a. Then this should be equivalent to what? To 18. From the other side, then for the imaginary part, we have, if we factorize the I there, you're going to have 3a squared minus 1. So we have 3a squared minus 1 is equal to 26. Okay. So what are we supposed to do now? Our goal is very simple here. Our mission is very, very simple. To just find the value of a. So 3a squared is going to be 26 plus what? Plus a 1 there. We have 3a squared being equal to 27. 27 divided by 3, our a squared is going to be equivalent to what? To 9. So therefore a is either equal to negative 3 or positive 3. We can try this out in the other equation. So what happens if you put negative 3 cubed minus 3, put minus 3. So negative 3 to the power 3 is going to be a minus 27. Then if you put a value there, that is going to be a 9. Negative 27 plus 9 is going to be, is supposed to give us what? In a minus 18, which doesn't match up. What about if you try the positive value there? Try out the positive value, positive 3, positive 3. So you're going to have 27 minus a 9, which is basically equivalent to 18. So the only value that is satisfying the equation is what? The positive one. So you can forget about the negative one. And therefore, our value of a has been determined to be a positive 3 in that equation. Okay. One more, xyi is equivalent to 3x minus y plus 12i. How do you get to simplify that? So our goal is to simplify it. How do you get to simplify it? We need to find the values of x and y. So on the left hand side, we can clearly see that you only have the imaginary part. On the right hand side, what do we have? 3x minus y. That is already the real part. The 12i is the imaginary part. So I'll equate the imaginary part, which is xy, being equal to 12. That is the imaginary part because it is attached to I. For the real part, this side will have a 0. That is our assumption. We have what? We have a 0. So therefore equate 3x minus y being equal to what? 0. So in that equation, you can make y to be the subject. 3x is going to be equal to y. So we've made y to be the subject, and we can get that value and plug in there. So where there is our y, we'll put what? 3x. Should be equal to 12. So we're going to have 3 what? 3x squared being equal to 12. And divide by 3, your x squared is equal to 4. So value of x is either negative 2 or positive 2, because the root of 4 basically is plus or minus of it. So we have two values of x. Then we can find the values of y. So y is going to be equal to 3x. So for the first value of x, we are going to have negative 6. Then if you get to plug in the positive value, you have a positive 6. So we've solved this equation. Okay, let's try to look at this interesting question. We've moved away from the equations now. Now let's say we have 5 minus 2i over z. Then that should be equivalent to 2 plus what? 2 plus I. Find z in the form of a plus ib. Find z in the form. So we need to find our z in the form of a plus what? ib. How do we get to do it? So we want to make z the subject of the formula. So you cross and multiply. So we're going to have our z being multiplied by 2 plus I should be equal to 5 minus what? 2i. So our z is equivalent to 5 minus 2i over what? Over 2 plus I. And at this stage, we've seen that it has basically gone back to the form of the question that we've been looking at, which just requires you to multiply by the conjugate 2 minus I, 2 minus what? I. So when you look at the question, whether you've not seen it somewhere, whether you've seen it or you've not seen it, don't be intimidated by the question. Okay, approach it, solve it, it's solvable. That's the good part about math. So 5 multiplied by 2, we have a 10. 5 by I is going to be minus 5i. Negative 2 by 2 is going to be a minus 4i. The negative 2i by negative I is going to be a plus 2i squared. Over what? 2 times 2, it's a 4. I times negative I is minus I squared. So we have 10 minus 9i. 2i squared is the same as minus 2 over 4 minus I squared is the same as 4. I squared is the same as negative 1. Okay. So even there on the numerator part, 2i squared has become minus 2 because I squared is negative 1. So the same is going to apply to the denominator. 4 minus I squared becomes 4 plus 1 because I squared is equivalent to a negative 1. So we have 8 minus 9i over 5. So we have 8 over 5 minus 9 over 5i. So we've simplified that. We've expressed our z in the form of a plus ib. Okay. We have another interesting question, which is basically the last question in this video. We've been given that our z1 is equivalent to 3 minus 2i. Then we've been told our z2 is equivalent to negative 1 plus I. Then we've also been told that our z3 is basically equivalent to 3 plus, so 3 plus 2i. Okay, so perform each of the following operations. So we need to express our solutions in the form of a plus ib. The first question requires us to simplify this. So there's a bar on top of a z there. So a bar on a complex number indicates us it's a conjugate that you're interested in. So we've already been given our z1. We've already been given our z3. So let's find the conjugate that we are supposed to put on the denominator. So the conjugate of z3 requires us to change the sign, right? So the sign is supposed to change. So it's going to be 3 minus 2i. So we can then substitute in the equation. So where there's z1, I'll put 3 minus 2i. Then where there's z3, I'll put 3 plus 2i over, we are dividing by what? The conjugate z3. So we have 3 minus 2i. So this thing is just a matter of you understanding what the symbols represent. Then you're home and dry. So let's try to expand what we have. 2 times 3 is going to give us what? A 6. 2 by negative 2i is going to be a minus 4i. Negative 5 by 3 is going to be a minus 15. Negative 5 by 2i is going to be a minus 10i. Over what? Over 3 minus 2i. So where are we now? 6 minus 15. 6 minus 15 is what? Negative 9. So I have negative 9. Negative 4 minus 10 is a minus 14i. Over what? Over 3 minus 2i. At this stage, this is easy. It only requires you to multiply by the conjugate for you to be able to express it in the form of a plus what? ib. So multiply by 3 plus 2i, which is the conjugate of what? The denominator there. So what do we have? Negative 9 multiplied by 3 is a minus 27. Negative 9 by 2 is going to be a minus 18i. Negative 14 I multiplied by 3. So 14 by 3 is basically a 42. So I have minus 42i. Then negative 14 by 2 is going to be minus 28i squared. Over that, 3 by 3, we have a 9 minus 4 I squared. 3 by 3 is 9. Negative 2i plus multiplied by 2i is going to be that. So we have negative 27. Then 18 plus 42 is what? 18 plus 42. So that is a 60. So minus 60i. Then where there is I squared, we're going to put a negative 1. So we have a positive 28. Over what? 9 plus 4. Because I squared is negative 1, so it will become a positive. So 28 minus 27 is a 1. Minus 60i over 9 plus 4 is going to be a 13. So I have 1 over 13 minus 60 over 13i. So we've expressed that in the form of a plus what? A plus ib. So the basic idea is for you to understand what the given symbols are representing. So I've got 2 more. Let's say you have z2, that's z1, over what? Over Z3. What are you supposed to do there? So that symbol there with a bar Z2 means that it's a conjugate. So what's the conjugate of Z2? It's -1 minus I. Then Z1 is 3 minus 2I. Then on the bottom part, Z3, which is 3 plus 2I. So what do we want to do at this stage? We're trying to divide and multiply on top. So on the numerator, -1 multiplied by 3 is a -3. -1 multiplied by -2 is a +2. -I by 3 is a -3i. -I by -2i is going to be a +2i squared over 3 plus 2i. At this stage, we have 2i squared is going to be -2. So -3 minus 2. 2 minus 3 is going to be -i over 3 plus 2i. That is going to be -5 minus I over 3 plus 2i. At that stage, how do we get to simplify that? We need to multiply by the conjugate of what? The denominator, which is going to be 3 minus 2i, 3 minus 2i. -5 multiplied by 3 is going to be a -15. -5 multiplied by -2i is going to be plus 10i. -I by 3 is going to be -3i. -I by -2i is going to be +2i squared over 3 by 3 it's 9. 2i by 2i is going to be, so that is like 2 times -2 is -4. Then I what? Squared. So we have -15. 2i squared is going to give us -2 because I squared is -1. 10i minus 3i, that is going to give us a 7i. On the bottom we have 9 plus 4 because I squared is -1. So I have -17 plus 7i over 13. So I have -17 over 13 plus 7i over what? 13. So we simplify this one as well in the form of a plus ib. For the last one, we've been given z2 squared over z1 conjugates. Okay. So for our z2, we have -1 plus I squared. Our z1, the conjugate is what? You change the sign in between it to become positive. Try to expand the numerator there. -1 multiplied by -1 is going to be a 1. -1 by I is going to be what? So what I'm doing is this. So that is going to be a 1, a minus I plus I squared. So we have 1 minus 2I minus 1. Okay, I squared is -1. So 1 minus 1 is basically going to give us what? 0. So we are just going to remain with a 2i over 3 plus 2i. Then at that stage we can multiply by the conjugates, which is 3 minus 2i, 3 minus what? 2i. So 2 by 3, we have a 6i. 2 by a 2, that is going to be a minus 4i squared. Then on the denominator part, what do we have? 3 by 3 is a 9. 3 by 2i is going to be minus 6i. 2i by 3 is going to be a 6i. Then we have a minus 4i squared. So we have 6i plus 4, because I squared is negative 1. So we have 9 plus 4, because I squared is what? Negative 1. So we basically have 6i plus 4 divided by 13. So I have 6i over 13, 4 over what? 13. So we've simplified our complex numbers. So this marks the end of our tutorial. Just a few tips just before you go. Reminder, you need to understand that basically your I squared is equal to negative 1. And your I is therefore the root of negative 1. Okay. Whenever they ask you to simplify, basically note that if you're given you I to the power 200, for example, just express it in the form of I squared, so that it will be I to the power 200. If it is raised to an even number, it's going to be a positive 1, because I squared is negative 1. Okay. If it is raised to an odd power, it's supposed to be what? It's supposed to be a negative. So now let's say you have I201. That is going to be I200 multiplied by I. So that you simplify your I200, which is 2 to the power 100 multiplied by I. And since you know that your I to the power 2 is negative 1, which is going to give you a 1, so you have a 1 multiplied by I, giving you answer as I there, which is equivalent to the root of negative 1. Then the other thing to note is when you're looking at the equations where they get to give you unknowns on one side, all it requires you to do is basically gets to equate the real parts on one side to the other parts and the imaginary parts as well. You'll be able to find the unknowns in such a case. Then whenever you see a bar on a complex number, it tells you that it's a conjugate. So given that the original complex number is a plus ib, its conjugate is going to be a minus ib. Okay? Then in a case where you are adding and subtracting, just go by the like terms. For division, when you have a plus ib being divided by x plus iy, it just requires you to multiply by the conjugate of the denominator. Okay. You just change the sign of the imaginary part. Okay. So I hope that this video has helped you to understand complex numbers without any challenges. Thank you very much for watching.